Let us now look at this final form of a line, which is your distance form of a line, or it is also called as the parametric form of a line. In my opinion, this is one of the most powerful. This is one of the most powerful forms. So you have seen different ways in which I can write the straight line. This is one of the most powerful ways. Why? Because using this you can locate every point. You can locate every point on the line. So let's see what this means. So basically you have a line, this pink line. You know its slope. So if you know theta, you know tan theta, right? So you know its slope. And what you know is a point on this line, a known point, which is your x1, y1. Now, let me take a general point xy at a distance r from this Q. So if I take this general point, what I can do is I can construct a triangle like this. This is your 90 degree. Now, this angle will be equal to theta, right? Because this and this are parallel, and this pink line is a transversal, so this will be theta. This is also theta. What is this? This is your x1 minus x, right? X1 minus x. And what is this one? This is your y1 minus y. And this you can always explain it to yourself because we've been using this again and again. So what is tan theta in the triangle? Tan theta is nothing but y1 minus y by 1 minus x. Or you can also write this as y minus y1 divided by x minus x1. Now tan theta can be written as sin theta by cos theta is equals to y minus y1 by x minus x1. Oh, if I rearrange this, so what I'll get is x minus x1 by cos theta is equals to y minus y1 by sin theta. But how am I getting this r? That is the question. So that is not very difficult to answer, because just take cos theta from that triangle. Cos theta is nothing but adjacent. Adjacent is your x1 minus x, and hypotenuse is your r, right? So this r is a real number, right? It can be negative, positive, anything. So I can also change this to x minus x1 divided by r, because r is just a real number. It's just a magnitude here. So cos theta can be written as x minus x1 by r. So r is nothing but x minus x1 by cos theta. So x minus x1 by cos theta is r, but x minus x1 by cos theta is also equal to y minus y1 by sin theta. So all of this is equal to r, right? So all these three are equal. So this is the form. This from here you will get this form. Now the thing here is, how does this help me get every point on the line? So here you have x1, y1 as your known points. You have the slope of the line, tan theta. So from that you can get cos theta and sin theta. But for different values of r, you will keep getting different points. So in fact, I can say that this is equal to plus or minus r. Maybe if I have plus r, then that would mean a point which is at a distance r but on this side, right? So you have a point which is at a distance r on this side. You might also have a point which is at a distance r on this side. So there's nothing wrong in writing plus or minus r. So what I mean to say is that I keep changing r from minus infinity to infinity. I'll keep getting different points. For every point there will be a unique r. So this is what you mean by the distance form of a line, the parametric form of a line. I hope you have realized that with this, from a known point, you can get any point at a distance. So for instance, if I have a question where I know the equation of the straight line from which I can find the slope of it. So if I know the equation of the straight line ax plus by plus c is equal to 0, what I know is tan theta is equals to minus a by b. So from that I can find theta, right? If I know tan theta, I can get cos theta and sin theta, right? I can get these two. But if the question asks you that okay, if I have this point 2, 3, find me a point which is at a distance 5 units. So then you can use this particular formula, because then you will put r is equal to plus or minus 5. For plus 5 you will get a particular xy. For plus 5 you will get an xy. For minus 5 also you will get some x dash y dash, and this will be at a distance of plus 5 units. This will be at a distance of minus 5 units. Or this is at minus 5 and this is at plus 5. But whatever it is, if this is at minus 5, then that will be at plus 5. If this is at plus 5, that will be at minus 5. So what will be plus, what will be minus, that can't be said right now. That you'll have to look at the problem and analyze it yourself. But you can always find the distance. You can find a particular point on the line at a particular distance from a given point. This is the power of this parametric form of a line. So with this done, let's move on to the next subtopic.